All right, guys, this is a video on matter and the properties that matter has and the changes that matter can go through. This is an introductory video. It's one of the first ones you'll see in Unit 1. So let's talk about what matter is to begin with. It's just anything that has mass and occupies volume. Matter is all around you, stuff you can see, stuff you can't see, and it comes in a couple of different forms which you're probably already familiar with. So the phases of matter that you're likely to know already are these guys: gas, liquids, and solids. And for our purposes, we want to think of matter as made of tiny particles, which in chemistry we're going to call atoms or compounds or molecules. There's a lot of different ways to describe particles, but this term particles is going to come up pretty frequently. So in a gas phase, the particles of matter, they move really freely. They have an indefinite shape and volume. That means that the shape of the gas is just whatever shape of the container that's holding it, and the volume is indefinite, meaning that it can be changed by compressing it. You can change the volume to expand a gas or to contract a gas. And that's really the only phase of matter that you can do that to. Liquids, the particles that make up liquids, the motion of those particles is a bit more restricted. You know what a liquid is. It sort of flows. It's got an indefinite shape, which means, of course, it just takes on the shape of whatever container's holding it. And it's different from a gas because it's got a definite volume, meaning that you can't compress a liquid into a smaller space. And then solids, these guys, the particles that make up a solid substance, the motion of those particles is highly restricted. They don't really move around like the particles of gas or liquid can. They just sit tightly next to each other. If there's movement, it's sort of in the form of like a vibration sort of motion of the particles. These guys have a definite shape and a definite volume. That means that the shape the shape of a solid is what it is. It doesn't take on the shape of a container or anything like that. And of course, you can't constrict the volume of a solid substance. So those are the three phases that we talk about here in chemistry class. And so let's talk a little bit more about matter. First, though, part of this definition is mass. And mass is just a measurement of the amount of substance present, okay? It's not to be confused with weight. Mass is a measurement of how much substance is present. All right, and chemistry is the study of all of that matter. It's the study of matter and the changes that can happen to that matter. Those changes are what kind of the cool part of chemistry is. So in terms of matter can be broken down into two basic categories. We can have pure substances or mixtures. Pure substances just means that there's only one type of particle present, and those substances are elemental substances or chemical compounds. And chemical compounds, you got to understand that even though there might be more than one type of atom, those atoms are bonded together to make a single particle, and in a compound substance, there's only that kind of particle. Okay, so elemental substances, believe it or not, are a bit rare in your world. You don't see too many of those in your day-to-day. What you do see a lot of are mixtures, and there's a couple of different types of mixtures that we'll talk about too. A mixture is just more than one type of substance that's mixed together, all right? And there's no real chemical connection between the substances. They are just standing next to each other doing their thing. The substances that get mixed together will retain their individual properties. So one of my favorite ways to describe this is like if you're making a strawberry banana smoothie or something like that. You put some strawberries and a banana into the blender and you mix them up really well together, and the smoothie that comes out, you can identify the taste of strawberries and banana, and that's because those two substances are only mixed together. You're not chemically changing either one of those things to make a new compound. They are just mixed in together. All right, so the types of mixtures that we have are called homogeneous mixtures, and these are substances that get mixed so thoroughly that the overall mixture has a uniform consistency. The substances that are mixed really can't readily be identified as separate substances, at least by looking at it. And the entire mixture will have uniform properties and consistency. Okay, so homogeneous mixture, it might be like if you wanted to mix red paint with white paint to make pink paint. You'd want to mix it really, really thoroughly so you get a uniform color of paint or something like that. And then the other kind of mixture is a heterogeneous mixture. And this is where the substances are mixed, but they're really easy to identify individually. Gosh, these are all over the place. I always talk about rice and beans, for example. You can easily tell the difference between rice and beans. And if you have a bowl of that in front of you, that's a heterogeneous mixture where it's not totally uniform in consistency. There's beans in one place, rice in another place. You could easily separate the two. And both types of mixtures can be separated. The homogeneous mixtures are maybe a little bit tougher to separate, but the key to understanding this is that it's a physical method that separates a mixture. So that could be something like using a magnet to pull iron shavings out of a sand pile or something like that, or filtering. Those are physical processes. Okay, so now in terms of properties of matter, whether we're talking about mixtures or pure substances, we want to talk about the properties. Like the biggest question to ask when you're determining things to be either chemical or physical properties is asking yourself the question, can that property be determined by just a simple observation or a very simple scientific tool? And if the answer to that question is no, then you're dealing with a chemical property. And chemical properties of matter depend on how a substance will react, usually in the presence of some other substance. So the big word to know here is reactivity. That is a key word to understanding chemical properties. These are just examples. The ability to oxidize, that's like rusting, and the ability to burn, perhaps. These require other substances and pretty thorough testing to recognize a chemical property. On the other hand, if you can just make a simple observation of a substance, that is usually a physical property. And physical properties are things like density, color, smell, melting point, boiling temperature, and there's lots more that you could probably come up with. These are just easy ones to basically just make a quick measurement of or just observe using your senses. These guys, by the way, these are known as intensive properties. And that just means that no matter how much of a substance you have, an intensive property will describe that substance. So like, for example, gold. Gold has a gold color, I guess you could say, and whether you have a tiny little nugget of gold or a big old bar of gold, it's still going to be the same color, right? So these intensive physical properties, they just apply no matter how much of the substance is present. These guys down here, though, mass, volume, and weight, these are known as extensive properties. And extensive just means that to make an appropriate value of the property, you have to actually measure these things, and the amount of the substance that is present determines these extensive properties. So extensive are kind of like mass specific, and the intensive properties are not mass specific, if that makes sense. Okay, so now that we understand some properties of matter, let's talk about the way that matter can change. And this is where chemistry really comes into play. So the way that we can change matter is in two different ways, chemically and physically. So we'll talk about the chemical change first. This one is this is what chemistry is all about, is changing the identity of a substance. And these happen in your day-to-day life all the time. Here's a really good example of a chemical change to this molecule. This is the chemical formula for something called glucose, which is in your body, and it reacts with oxygen to make energy. But as a result of this reaction, we actually form two new substances that are completely different than what we started with over here. This arrow represents just a chemical reaction taking place. And you can see that the identity of these things over here on the left is totally different than the identity of these things on the right. And that's an indication of a chemical change. Okay, physical changes, these can be really cool as well. The properties of a substance might change, but the identity of the substance doesn't. And there's just a million of these you could probably come up with, but like things like cutting a piece of paper in half obviously doesn't change what that stuff is made of. Bending a piece of metal doesn't really change the metal, of course. You can dissolve a substance in water, it doesn't change it. Break something, crush something, and there's just a million more that you could probably come up with. But the idea is that you don't really fundamentally change the identity of the substance in a physical change. Some physical changes that are a little more, people kind of forget about these. Any change to the phase of a substance is a physical change. So you would probably agree that water that freezes into ice, that is still water. It's just in its solid form instead of liquid. So anytime you're just moving from like liquid to solid, these are like freezing. Oh, my pen's going bad here. Freezing and melting. These are physical changes. Solid to a gas, this is a pretty interesting process. This is known as sublimation or deposition. And then gas to liquid, this is evaporation and condensation. And so lots of students just sort of forget that these phase changes are just physical changes. So keep that in mind. And the last thing we're going to talk about is just visualizing the difference between elements, compounds, and mixtures. And I have a good way to do this. This is a little model that you'll see on one of your practice sheets. And so let's just take this first example here. These little dots here, these black dots, each of those dots represents a single type of atom. And because they're all these black dots here, they're all the same kind of atom, that means that this is an elemental substance, okay? Another way to look at these is if you have two different types of atoms. We got the black ones and the white ones. And you'll notice here that the little circles are not in contact with each other. And that means that there's no chemical bond between the two of them. They're just sort of standing there together. That indicates a mixture. And this is what you would just visualize as a mixture of elements. And then here we get into a compound. So you'll notice here that we have different types of atoms, black ones and white ones here, but because they are in contact with each other, that means that there's some sort of chemical bond occurring that actually changes these elemental substances into a new type of substance. And because there's only one type of this substance here, this is what we call a compound. And knowing, I think this will help a lot. Anything with a chemical formula is a compound. So, for example, H2O. These, maybe these are water molecules, right? 2 hydrogens and 1 oxygen. So this would maybe be representing pure, just nothing but water, pure compound water. Lots of things have chemical compounds, lots of things have chemical formulas, and those mean it's a compound, okay? And then the last one here, this is where we take compounds and we mix those compounds together. So you'll notice that we do have these compound substances here, but we have more than one type of the compound substance. And so we might have, you know, some substance here represented by this structure, and then another substance represented by that structure. And while there is contact between these little circles here and each individual particle, the particles themselves are not in contact with each other, which means it is a mixture. So this would be a mixture of compounds. All right, so lots more to talk about with this stuff, but we'll pick up on that in the next video.